Today we're going to look at something that we're quite familiar with, but we're going to use a little bit different vocabulary to describe it. Today we're going to talk about proportions. A proportion is just a statement that two ratios or rates are equal or equivalent. So sometimes you'll be asked a question like, are these two ratios equivalent? We have an example here, 14 cents for every 18 customers and 7 cents for every 9 customers. In order to see if they are proportional or if the ratios are equivalent, what we need to do is we can put them in a ratio table, which is what we've been doing. And we can look and we can easily see that if I divide 14 by 2, I'm going to get 7. And if I divide 18 by 2, I'm going to get 9. Okay, nothing new there. Okay, but now we're going to look at it slightly differently. Instead of in a ratio table, we're going to look at this as fractions. And we're going to see, are these fractions equivalent? 14 cents, 18 customers. Is that equal to 7 cents for 9 customers? All right, well, let's see again. Look at the fraction 14 over 18 and the fraction 7 over 9. You can probably see that all we're doing here is simplifying the fractions or the ratios, right? We're dividing 14 over 18 by 1 in the form of 2 over 2, and we're getting 7 over 9. So we say that these are proportional or they form a proportion. Okay, let's look at another example. We are comparing here 9 pies for every 5 cakes. I'm sorry, 3 pies for every 5 cakes and 9 pies for every 15 cakes. Again, let's see what we can do in the context of a ratio table. Here, if we multiply 3 times 3, we're going to get 9. If we multiply 5 times 3, we're going to get 15. So these do form a proportion because the ratios are equivalent. If we choose to look at this as equivalent fractions, okay, if we multiply this by 3 over 3, which we can do, right, because that gives us 1. 1 is the multiplicative identity, so it doesn't change anything when we multiply. And we get 9 over 15, or 9 pies for every 15 cakes. Okay, so those are the same rate or the same ratio. Now, let's go to a different example. Okay, so I have a couple here, a couple of speeds, and we want to see if these speeds are proportional. Okay, so let's look at the first one. In order to get from 2 hours to 1 hour, you can probably see I have to divide by 2. Okay, so I'm going to have to divide this by 2 as well. And when I divide 50 by 2, I do not get 20, I get 25. So therefore, these are not proportional. Okay, and now let's take a look at this one down here. Another speed, because a lot of times we're dealing with speed. Speed is it's more than just a ratio. Speed is a rate, and we're going to do a lot more with that at a later date. Okay, so let's do this. Let's see. Let's see. If you see that I can't draw a relationship directly between 3 and 2 or between 150 and 120. But what I can do is I can take my 150 miles in 3 hours, and I can find what? I can find the unit rate. Okay, and how am I going to do that? I'm going to divide both quantities by the denominator. Okay, so I'm going to divide by 3 over 3, which is equal to 1. And what do I get? I get 50 miles in 1 hour, or 50 miles per hour. Okay, so that's the first one. Okay, that's this. And now let's do the same thing up here. Okay, so let's take 120 miles in 2 hours. And we're going to divide that by the denominator, which is 2. So 2 over 2. And what do we get here? In 1 hour, we get 60 miles, or 60, we can also write it like this, miles per hour. Okay, so 60 miles per hour, 50 miles per hour, these are not proportional. Okay, so sometimes you have to have a middle step just like in a ratio table. Sometimes you need to find the unit rate. All right, so whatever we want to call it, equivalent ratios, equivalent fractions, proportions, they're all done the same way. So even though we're introducing new vocabulary, this is nothing new to us, so we can all feel comfortable that it's not a new concept. It's just calling it by a new word.